This is chapter 25, lecture 1. So, in nature, there exists four basic forces. The four basic forces are as follows: 1. Gravitational force. 2nd force is the weak force. 3rd, electromagnetic force. 4th, and finally, the strong force. The strong force was also called earlier as the nuclear force. In this chapter and the next couple of chapters, we will study various aspects of electric and magnetic forces. So let us begin our study of electric forces. Electric forces act between charged particles. There exists two types of charges. One is the positive charge and the other is the negative charge. We will be specifically studying the case wherein these charges are at rest. Now, the SI unit of charge is the Coulomb. SI unit of charge is Coulomb. And it is given the symbol capital C. It is a known fact that like charges repel and unlike charges attract. That is, if we have two particles or two objects that are both positive or both are negative, then these charges will repel each other. That is, they will push each other away. Whereas if we have a positive and a negative charge, then there is a force of attraction between these two charges. And this is an experimentally verifiable fact. The smallest unit of charge is that of the charge of an electron. And its value is equal to 1.6 into 10 to the power minus 19 Coulomb. The charge of an electron is negative. Now let us introduce the principle of quantization of electric charge. The principle of quantization of electric charge. Whenever we want to create a charged object, usually objects in nature are neutral, that is, they do not possess any charge, but we can create a charge on these objects, or we can create charged objects. So whenever we want to create a charged object, the way it is done is by transferring electrons. Suppose we want to create a positively charged object. The way we can create a positively charged object is by removing electrons. So this is a neutral object. If we remove electrons from this object, then this object becomes positively charged. And if we want to create a negatively charged object, we add electrons to this object. If we add electrons to this object, then this becomes a negatively charged object. Now, what the principle of quantization of electric charge states is the following. Whatever charge that we produce in nature, let's say it is Q. It could be positive or it could be negative. Whatever is the charge, it is always an integral multiple of the charge of an electron. Mathematically, we can write it in the following way. Q, let Q be the charge that we want to produce. Then, this Q is an integral multiple of the charge of an electron. Now, when n equal to 0, it means that the object is electrically neutral. It does not have any charge. Any other charge will be integral multiple of the charge of an electron. Or in other words, we could say that whenever we transfer electrons, we could add electrons or we could remove electrons. It will always be done as a full electron. We can never transfer half an electron or 3/4 of an electron. And this is called the principle of quantization of electric charge. Now we are in a position to study and quantify the force of attraction or repulsion that exists between two charged objects. The quantification of the force of attraction or repulsion between two objects is given by Coulomb's law. Let us state Coulomb's law. Coulomb's law states that if we have two charged objects, Q1 and Q2, it doesn't matter here whether Q1 is positive and Q2 is also positive, or Q1 is negative or Q2 is negative, or Q1 and Q2 are unlike. What Coulomb's law tells us is, if we have two objects, Q1 and Q2, and if they are separated by a distance r, then the force of attraction or repulsion between the two charges is proportional to the product of the two charges and square of the distance between them. These two vertical lines mean that we are only taking the value of the charge. We are not taking into consideration the sign of the charge. This proportionality constant can be replaced by an equality and we get F equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. This 1 by 4 pi epsilon 0 is specific to the SI units that we will be using. Epsilon 0 is called the permittivity of free space. Of free space. And the value of epsilon 0 is equal to 8.85 into 10 to the power minus 12 Coulomb square per Newton meter square. It is very easy to see from where this Coulomb square Newton meter square appears. Let us look at this formula. Suppose we move this epsilon naught to the other side of the equation and we bring F to the denominator over here, then what we get is 1 by 4 pi is a constant. Q1, Q2 are in the numerator. SI unit of Q1 is Coulomb. SI unit of Q2 is Coulomb. So therefore we get Coulomb square in the numerator. R square is in the denominator. Therefore we get meter square in the denominator because meter is the SI unit of distance. And since this force has been brought down to the denominator, we get a Newton here. So that is how we can see how this Coulomb square per Newton meter square appears in this formula. Now what we have shown is the scalar form of Coulomb's law. What do I mean by that? We all know that force is a vector, whereas the Coulomb's law that we introduced just now, that is F equal to 1 by 4 pi epsilon naught, this does not have information about the direction in which the force acts. There is no directionality information in this equation. So what we will do now is we will write the vector form of Coulomb's law. Vector form of Coulomb's law. For this, consider two charges as before, Q1 and Q2. For the sake of simplicity here, let us choose Q1 and Q2 to be positive. We know that like charges will repel, and this information will now be captured in the vector form of Coulomb's law. What we want to do now is we want to keep the charge Q1 fixed, and we will take this as a reference point. And it is with respect to this that we will write the vector form. This is reference. Let's look at the vector form. Force on Q2. Notice the first subscript 2, it indicates force on charge Q2 because of Q1 is equal to 1 by 4 pi epsilon naught. Many textbooks abbreviate 1 by 4 pi epsilon naught with a capital K. Force on Q2 because of Q1 is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R21 square multiplied by R21 hat. So we will go into a little bit detail on what this R21 hat is. R21 hat is a unit vector whose tail is at Q1 and the tip of the arrow is pointing in the direction of Q2. So this is R21 hat. So it's a unit vector. Notice that this square in the denominator is just the distance square. That is the distance of Q2 from Q1. Now what is the direction of F21? The direction of F21 is as shown by this arrow. It is worth mentioning here that the force between any two particles is along the straight line joining the two particles. So what do I mean by that? If you look at the F21 arrow, you will see that it is a continuation of the straight line which is joining Q1 and Q2. You will never find F21 in an arbitrary direction like this. So these red arrows are not valid. Force always acts along the straight line joining these two charges. So therefore, finally, this particular equation is the vector form of the Coulomb's law. Once again, note that the Q1 and Q2 that appear here, you don't have to include the sign of the charge here. The vector R21 takes care of the fact whether the force is repulsive or attractive. So let us look at another scenario wherein we choose Q1 and Q2 to be unlike charges. So if Q1 and Q2 were unlike charges, so this is Q1 and this is Q2, and I want to find out what is the force on Q2 because of Q1. Here we take Q1 to be positive and we take Q2 to be negative, and as before we choose the distance to be R. Now we know unlike charges attract, so therefore the arrow, the force will be in this direction, and the magnitude of this force will be given by force on 2 because of 1, we can write the magnitude in this fashion. Magnitude of the force on 2 because of 1 equal to 1 by 4 pi epsilon naught, which we can abbreviate with a capital K. This is capital K. Q1, Q2 divided by R21 square. In the next lecture, we will look at some numerical examples based on this formula.